Okay, so this is actually almost all about the HTTP protocol. This is basically how it works. We have HTTP request and we have HTTP response. And let's just briefly talk about this status codes. Whenever you make an HTTP request, server may respond with different kinds of status codes. And each status code has a brief description that we call status message. Let's look at HTTP status codes. I will look for the internet. Let's look at this Mozilla Developers Network. And we have some range of these status codes. For example, if the status code is between 100 and 199, it's just some informational responses, and this is not very common. You will not see a lot of these status codes whenever you receive an HTTP response. And the response codes between 200 and 299, these all are successful response. Okay, for example, I will look at some responses. For example, we have 200, which means the request was succeeded. It means everything was okay. For example, 201, it means whatever the resource you wanted to create, it was created. I don't know, this means accepted, this means non-authoritative information. I don't even know what does it mean. This means we have done everything we agreed, but there is no content. Like, I don't have anything to show you, but I've done your work. Like, we have a lot of response codes. Okay, so this all which are starting from with 2, it means successful. The ones which are starting with 100, it's just informational responses. Then we have 300s, and 300s means just some redirection. For example, whenever you visit a link and this links redirect you to some another link, for example. Let's actually you find the URL shortener. Okay, I will find the URL shortener. This website is down for some reason. Let's shorten some URL. Let's look at some. I don't know. Wikipedia. Don't know. Era dos pensive. Let's look. Okay. Let's say it's just this URL is long. I'm shortening this URL. You have seen a lot of these short URLs. For example, this is my short URL. Okay. I'm just pasting it here. Let's look at this. And actually, this short URL should redirect me to Wikipedia. Okay. Whenever I visit this short URL, let me open my network tab here. Okay. I opened my network tab, I clear it, I preserve logs. I will visit this short URL and it will redirect me to Wikipedia. Okay. It will redirect me to Wikipedia. I see this Wikipedia page here. And let's look at this request, what I've made the request. Okay. I've made request to this URL and it responded with 301. And we told that the ones starting with 300 means the redirection responses. Okay, I will look at this 301. What this means? It means that this website is moved permanently to wikipedia.com. Okay, there are a lot of like codes which start with this 300. They all just different versions of redirections. Okay, whenever server responds with 300, it means that it redirects you somewhere. Then we have the ones starting with 400, like the ones start with 4, actually. They all means client error response. It means that you have done something wrong. As a client, you have done something wrong that they couldn't find it. For example, they couldn't process your request. Okay, let's say in this example, I'm looking for inside image folder, I'm looking for ASDF PNG. Okay, whenever I request for ASDF PNG, server will look at its folders and files, and it will see that it has this image folder, but it doesn't have this ASDF PNG. So it will respond me with some different status code, which, for example, which is called 404, which is called not found. Okay. Which is called not found. 404 is very popular status code, which just means not found. Actually, I think in some hotel rooms, I don't know which hotels, the room number 404 usually doesn't exist. It's as a joke. Like you can go to 403 and then you can go to 405, but room number 404 doesn't exist, just as a joke for HTTP. That's hotel room 404. Error 404. I don't know. You can find examples, but yeah, I don't remember any exact examples. Okay, like the ones which are started with 400, it means that client has done something wrong. The ones starting with 500 till 599, it means that server has done something wrong, or server isn't actually able to process this request. Okay, server is doing something else. I don't know, server is busy, server is down, it is burning, I don't know. It means that server is messed up. Okay. Status codes, meme, I don't know, they should have some nice yeah, for example, this meme is nice. Example, the one started with 404. Server says that it's your fault, but the ones start with 5. It like server says that it's my fault. Okay. Okay. For example, if you have last year, when I was I want to pick up some house from Mida, you know Mida, Menzil İnşaatlar'a gitti. You pick houses here. Whenever, like everyone, whoever entered the website was down. So it was responding with, I think, 503. Let's look at what is 503. This is service unavailable. It means that service is down. I don't know if burned, whatever happened, it's unavailable. It cannot respond to us. Okay. This is usually happens a lot with Azerbaijan websites, because whenever a lot of people send HTTP requests to their server are not able to handle all of these requests, and they respond with this 500 requests. Okay. So these are some HTTP status codes that they might send you, that the HTTP servers might send you back. Okay. Okay. Let's look at some examples, some more examples to an HTTP protocols. For example, this is another example. Let's see. We send an HTTP request to this path name. This is called select beer taste. And we send some parameters along with, for example, I want my beer to be dark, and I want this taste to be malty. And I sent HTTP protocol version 1.1, and I have some headers. We always have this header, which is called host, because you need to know which host you are sending the request. Then we have some other headers, for example, accept encoding, JZip, I don't know, accept language, English language, accept formats, for example, I accept XML, HTML, I accept image, whatever you sent me. User agent header, for example, it means user agent means whoever sent the request. Usually, your browser is the one that is sending the request. So user agent is actually the name of your browser, usually. For example, here is the Mozilla, I don't know, on Macintosh system. The operating system is macOS, the language is English, etc. The another HTTP request, let's look at post, for example. In here, we sent a GET request. GET request means that I'm requesting a resource. I want to get something. Post request means that it's just a verb. The verb changes from get to post. For example, we have a lot of verbs. For example, we have get, we have post, we have put, we have delete, we have patch, we have a lot of stuff. Post means I want to send something to the server. I want this server to process my information. For example, in this specific example, this client making HTTP post request, and it is sending along some data. For example, it is sending this color and taste as a request body. Okay. In GET request, whenever you send some data, you send it in query parameters. After this question mark, you have your key and value, and sign, and key and value, then another and sign stuff. And in post request, you actually send your data along with request body. We have request line, we have headers, then we have request body, which is also called payload, like the payload that you are sending along with the request. For example, whenever you log into a website, you actually send your data to the server, like you send your username and your password, the server process your data. Okay, let's try to log into Facebook. Okay, I open the network tab, I clear it. Okay, let's write I write my password wrongly. Let's log in. Okay, here, for example, I sent a post request to facebook.com/login/ I don't know a lot of stuff. Then I sent my payload here. My payload here is email is orhan@outlook.com, and I have this password. They encrypted my password somehow. This password is like, they encrypted my password to something else. And yeah, this is basically the data that we are sending to the Facebook server, and Facebook server sent me an empty response. I think it redirected me to homepage, and it is telling me that what is telling me? It's actually telling me that like my password is not correct. Okay. Okay, so we use GET request to receive some data. We use POST request to send some data. We use, for example, delete request to delete something. For example, let's say I have my account. I want to delete my account. I will send HTTP delete request. Okay. So this is it, basically. Actually, this is like all about HTTP protocol. This is how it works. I will try to find more interesting videos and will try to send you. I will also show you with some code, like what HTTP server looks like on your computer. Okay. Actually, we can write it. I can show you a HTTP server that is running on my laptop. I can send it some HTTP request, and it will receive that request, and it will respond me back. Unfortunately, I won't write it with Python. I will write it with JavaScript. It's very simple. You don't need to understand it. Just look at it, and let's call it HTTP server JS. I will actually, for example, in Node.js, you also have some stuff like this. JavaScript. I create a server saying http.create server. Okay. Then I start I start my server at port 8080. Okay. Okay. This is actually 3 lines that I in JavaScript that I need to create. I need to write to create an HTTP server. Okay. Let's say I'm running this HTTP server. I will run this HTTP server.js. It is actually running right now. As you remember, for example, we had a UDP server here, right? In the UDP server, we were writing a while true, which consistently tries to receive some data. This HTTP server, actually server.listen, means that I am consistently waiting for some data. This is actually what all servers does along the world. For example, Facebook server is sitting there and consistently waiting for some requests. Whenever it receives some request, it actually responds to that request. Okay. Let me go to my IP address. What's my IP address right now? Okay. General Wi-Fi. Yes, my details. My IP address is this one, 181. Okay, I will go to, let's construct the URL. Okay, what will be my URL? HTTP // my IP address, then my port, then actually the slash is just okay. Okay, this will be my URL. Okay, my protocol, then // my host name, then my port number, then my path name. Okay, I will open a new browser tab and will inspect the network tab here and will send a request. Okay, I press enter, and as you see here, I sent an HTTP request to this IP address. Well, I have some request headers. For example, host header is this one. I don't know, I have some user agent which is put by my browser. I have accept language, accept encoding, etc. So the reason why the server is not responding is because I didn't write any code here to handle that request. I can write, for example, whenever you get a request, send some data, for example, hello world. Okay. Whenever my HTTP server gets a request, it means on request means whenever you receive a request, respond with hello world. Okay. And again, if I visit this website, it will show me this hello world message, and I can inspect it from here. For example, I sent HTTP GET request. Actually, I didn't send. My browser sent HTTP GET request to my web server, which is running on my local, and I have the response here. Response is just hello world, and the format, I think it's what's the content type? We don't have content type here. We have content length, for example. It means that it is only 13 bytes. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think 12, 13, 14. Why it show me 13? I don't know. Okay, I can actually send some headers. Let's write some HTML here actually. Okay, this means bold text. H1 means header in HTML. I will see it like this, for example, because I've sent an HTTP request and the server sent me this text. Whenever browser sees an HTML, your browser shows HTML like this. H1 means heading. That's why browser shows it in bold. You can write. We will talk about HTML in our upcoming lectures. After, I think, 3 lectures. After 3 lectures, we will talk about HTML. Okay, I can actually tell the browser that don't I can tell the browser that don't interpret it as HTML. This is actually plain text. Okay. Let me Node.js HTTP server send header. What was the header? Okay, set header. Okay, it's called set header. For example, I can tell the browser that content type is not HTML. Okay, content type is actually text HTML. Actually text HTML, not text plain. It means that it's just plain text. Don't look at it as HTML. Okay. Whenever I do it, my server will show it like this. Whenever I do this, my browser will show me this plain text because I told my browser that this is the text, but this is not HTML. This is just plain text. Whenever I say it, this is not plain text, this is HTML. My browser will show it as HTML. For example, if I look at my response, for example, in the response headers, we have content type text HTML. The content length is 22 bytes. Okay. So this is like very basic HTTP server that we can do. We can actually write some conditions here. For example, if, for example, request has what was the request URL? Yeah, request URL is, for example, let's say request URL is I don't know, hello, send hello. If the else if request URL is bye, send goodbye. Okay. Whenever I go to like hello, it will say me hello world. Okay, whenever I go to like hostname / hello, it will send me the hello. If I go to bye, it will send me this goodbye world. Okay, this is actually how all the websites in the world looks like works. They just look at your URL, whatever URL you are visiting, and you send you then they send you different data. Okay, you don't need to fully understand this code. This is just very basic code written in JavaScript. Most probably you can also do the same in Python. But the reason why I didn't show this Python because they have some stuff that we haven't covered in Python. This is basically a HTTP server written in JavaScript. And one last thing I want to say to you, whenever you want to visit some server, TCP server, HTTP server, doesn't matter, which is on your local, which means on your laptop, you don't actually need to write this IP address here. Okay, there is a special IP address which is like this. There is a special IP address. Okay, this IP address is this 127.0.0.1. This is called loopback IP address. This always shows your laptop. Doesn't matter wherever you do it like it always shows this device, this my device. If you write this IP address on your device, it will redirect this request to your device. Okay, this is called loop back IP address. And so you don't need to every time go and find your IP address from the settings. You don't need to do this. If you do this, if you write this loop back IP address, this browser will know that actually, not browser actually, your device will know that this IP address belongs to your own. Okay. So instead of this, you can also write localhost. Whenever we will talk about DNS, if you write localhost, it's also the same. Localhost. Sorry. Localhost instead of IP address. If you call localhost, it's also the same. Okay. Okay. What I was going to talk about, I forgot. I think. Yes, basically this. And just one more clarification about websites. As you see, whenever I go to facebook.com, I don't actually write port number here, right? For example, when I visited my own web server, I wrote this port number here. But when I visit facebook.com, I don't actually write port number. This is because browsers, your browsers, this Google Chrome, Firefox, whatever, they actually know which protocol uses which port number. For example, for HTTP protocol, default port number is 80. It's just 80. For HTTPS protocol, default port number is 443. Okay. Whenever I visit facebook.com, as you see, it actually makes request to this IP address, and port number is 443. 443 is default port number of this protocol, HTTPS. So I can write here 443, but it doesn't really make sense because my browser already knows that default port number for HTTPS is 443. Okay. They do it just for making our life easier. We don't need to remember. Like regular non-tech people don't know about port numbers or IP addresses. That's why we have this domain names and stuff. Yeah. Okay. Okay. Do you have any questions regarding to HTTP? No. Murat, Maksut, no.
No, everything's all right.
No, it's clear.
Okay. For today, the last and probably most important thing I want to talk about is DNS. DNS, which stands for Domain Name Service. Whenever we visit a website, whatever we do, we don't write IP addresses. We write domain names. We write facebook.com, we write, I don't know, twitter.com, twitch.com, I don't know. We don't write IP addresses. This is because as people, we don't want to remember numbers. We want to remember names because in our brain, we are easily can associate names with something. We don't want to remember numbers. So for this reason, we have a domain name service. Domain name service is just a dictionary which maps IP address onto a domain name. Okay. Let's say we have a domain name server. Domain name server means that it's just a device that knows which IP belongs to which domain name. Okay. For example, this one domain name server, let's say it knows that this IP address should go to local, I don't know, this domain name should go to this IP address. I don't know, this domain name should go to this IP address, I don't know, just for fun. And I don't know, this IP address this domain name should go to this IP address, etc. So domain name servers are just dictionaries, like any phone book, for example. They just remember which hosts like go to which IP addresses, and this is easy for us because we don't remember these IP addresses. We remember domain names. Whenever we visit a website, we actually write this domain name, and our browser actually has a DNS resolver, like it, not DNS resolver, but actually before our browser actually makes a HTTP request, our browser actually goes and tries to find the IP address of that domain name. Okay, that's why whenever I visit facebook.com, you actually see Facebook's IP address here. Because whenever I visited this facebook.com, my browser actually went to nearest DNS server and found that facebook.com's IP address is this one. And actually, now my browser actually remembers that in his own cache, not to look for it again, and remembers that, and stores it somewhere in my computer. Yeah. Let's actually I can clear my DNS cache. Let's see, run clear DNS cache. Let me just quickly clear host cache. Let's make this request again. Okay, this again found the same IP address, but let's just briefly look at this timing here. In my browser, I can look at this timing, the request timing. Let's see actually what happened. There should be something called DNS lookup. I don't see it. Waiting for server response, request sent, connection started, queued, initiator. Why it didn't clear my cache? Let me clear it again and make the request again. Yeah, I don't see it here. From network DNS lookup. Let me look at it with Firefox, maybe inspect network, go to facebook.com, inspect it again, disable cache. It's facebook.com here. Let's look at timings. For example, here DNS resolution, like it looking for IP address of this domain name. It took 0 milliseconds. It probably cached it already. Let's look for Firefox clear DNS cache. DNS cache entries. Click DNS option left-hand side of the menu. Where is my Firefox? I just want to show you. what? Networking will open about networking command DNS. Clear DNS cache. You see, Firefox already remembers some DNS entries. For example, this points to this address, etc., etc. I clear my DNS address. I refresh. DNS cache is empty right now. Let's make this request again. Facebook.com DNS resolution again took 0 milliseconds for some reason. I don't really know. Let's go to this again. It actually fetched this IP address and it actually remembers it here. Next time, whenever I do it, it actually won't go to the internet and look it again. And you might ask, like, DNS has also an DNS server is also a device which has an IP address, and we need to actually know IP address of DNS server to go and look for IP address. Okay. Actually, your computer already has this setting. For example, if I go to my network, if I go to this Wi-Fi, if I go to details, you will have here DNS. For example, these IP addresses are my default DNS addresses. This means that these are the IP addresses of DNS servers that my computer knows. I cannot delete them because if I delete them, next time I won't be able to look for any DNS entry. Like I won't be able to look for IP addresses. Okay. What happened? Did I delete them? No, I didn't. Okay. These are some domain name servers that my computer knows, and whenever it wants to search for a domain, an IP address of the domain name, it goes to these servers and asks for an IP address. Okay. Actually, all of your computers also have some domain name entries inside your computer. In Linux, it is inside a file which is called hosts file. For example, I have inside my etc folder, I have a file which is called hosts. I have here, for example, whenever I write localhost inside my browser, it goes to this IP address. Whenever I write attacker.com, it will go to this address as well. Okay. For example, let's say I write here attacker.com, it goes to the same address because I wrote here that whenever you go at attacker.com, go to my web, go to local IP address. Okay. I can actually change this file. Okay. I just opened this text file. And I add another entry here. For example, what happened here? Why I can't edit? I add another entry here. Okay. I say that whenever I go to facebook.com, redirect me to this IP address. Don't look for any other IP address. Okay. I can actually save this file. And let's go to facebook.com. You know, it tries to go to my local server, and that's why it doesn't open, because in my local server in port 80 there isn't anything running. If I run my HTTP server in port 80, actually it will open my web server. It's actually HTTPS. I go to http://facebook.com. Let's run it here. Maybe why does it go to HTTPS? Okay, just you get the idea, right? You can always change your host file here. You may even change someone else's host file if you get access to their computer, and then you can actually redirect them to different website. For example, someone wants to visit the original facebook.com, but you have built a copy of facebook.com and it's on another IP address, and then they can visit your version of facebook.com, and you can steal their data, and yeah. Now I removed that entry. Now I can go to facebook.com again. Okay, well, this is basically some stuff about domain name systems. So we have this domain name services are also there is some organization that manage this domain name servers. For example, if you look for root DNS servers, you remember this organization which was called IANA, Internet Assigned Numbers Authority. They maintain this root servers, which are just 13 domain name servers. We call them root servers because, like, whenever someone can't find a domain name for this IP address, they go to one of these servers, and then they redirect them to some other place. Like this is the last place that whenever you look for IP addresses, this is the last place that you go. Okay, and this is called root name servers. We only have 13 of them. All of these 13 names fail, 13 servers fails, we will probably have some problems with the internet. Okay. Do you have any questions regarding to domain name service, DNS? Nope. Okay. Basically, I think this is all I want to talk about today. I don't know if we have anything else left for networking. I think no. Yeah, we talked about domain names, we talked about HTTP, we talked about TCP/UDP. Just one last thing I want to show you. I will try to show you, but I don't know if I will be able to show you. Open Wireshark from terminal, Mac. Wireshark, Mac permission denied. Let me just show you quickly. Okay, you see my HTTP server is running on this port. Okay, I run my HTTP server on this port. We also talked about some low-level protocols like TCP, UDP, and stuff. We talked about TCP handshake. There is a program which is called Wireshark that you can inspect your network data inside Wireshark. I will send a request to this my own HTTP server, and let's see what actually happens inside our network. Okay, I go to localhost 8080, like my own server, localhost 8080. Was it running on 8080? Yes. Why isn't it responding? I don't know. Something happened here. Because I didn't actually handle this. Because let's go to hello. Okay. How can I clear this, please? Stop and quit without saving. Go to look back and then refresh. Okay. So let's actually, I don't know if I can zoom in. I can zoom in actually. Let's actually see what has happened here. Okay. It's just. Let's see what happened here. So you remember TCP three-way handshake? Like I sent SYN, then this another party sent SYN ACK, then I sent ACK, then we handshake. Okay. So you remember whenever I visit my HTTP server, the first thing that my browser does is to establish a TCP connection. Okay. For this reason, it sends a package which is called SYN, which is sequence number of 0. Then the server responds with SYN and ACK with the same sequence number. And then my browser also responds with this. You see this 8080. This 8080 is the port number of my server. And this long port number is the this 555 and stuff. Let me just, how do I remove it from here? Okay, yeah. So this 55671 is IP port number of my browser. Like this is ephemeral port number. From my browser to my server, there is a SYN package that's going. From my server to my browser, there is a SYN and ACK package going. And then again, from my browser to my server, there is an ACK package going. This 3 requests was for TCP three-way handshake. This just means that they have established a connection between them. So whenever they established a connection, my browser made an HTTP request. You see this get/hello HTTP/1.1. My browser made an HTTP request. Then my server sent an acknowledgement saying that, okay, I received your package. You remember whenever we send a TCP package, the other side should respond with the acknowledgement that I have received it. So the server responds that, okay, I received your package, and it also responds with HTTP 200 OK, which is text HTML. Then what happens? Then client also says that, my browser also says that, okay, I got your data, everything is fine. Then they close the message, they close the connection. For example, my browser sends a FIN package, which stands for finalize. And then server says that, okay, let's finalize. Then again sends a FIN ACK. And then it says ACK. And these 4 requests are just for closing the connection. It means that, okay, I sent you the data, you sent me the data, okay, we are done, then we, okay, so we need to close the connection. Okay, what else do we have here? Keep alive, keep alive. Maybe we can also look at some DNS stuff here. I'm not sure. As you see, if I go to my Wi-Fi, there are a lot of packets are coming, going. Let's look for DNS. Let's go to twitch.com. I went to twitch.com. As you saw, my computer made a DNS query, which is called DNS standard query, to somewhere, to some IP address. I don't know if we can see that IP address. For twitch.com, twitch.tv, actually it looked for twitch.tv, then it got some IP address probably. I don't know where is this IP address. So it receives this IP address and then does the same thing, establish TCP connection, and then it sends HTTP request and gets this data. So the point here is to actually, for you to understand what happens when you actually open your browser and type some stuff. I will try to send some videos to you, videos and articles that will also talk about this stuff. Hopefully, after these 3 networking lectures, you have like general idea of how networks, how internet works, and what happens actually whenever you go to google.com, facebook.com, etc. If you don't have any questions, we can finish the lecture. No? Okay,
No.
then.
No, it's not clear.
Okay, then have a nice night.
Also, Professor, do you remember that I said that I will not be able to join for 10 days? Like,
Was this the last lecture that you were able to attend?
yeah.
Then we will probably have some break if this is okay for everyone. Yes.
Like 10 days, approximately, max.
So we don't have next lecture. Also, we don't have next week. Then we will continue again, I think.
So like on 1st August, somewhere at that time.
Yes.
So if it's possible for everyone, that would be great.
Yes, we can vote on the WhatsApp. Probably it's okay, but we can vote on WhatsApp.
Okay, great.
Okay. Goodbye.
Yeah, bye bye, Professor.